reports, Turkey is looking to play a bigger role in Europe's security. It has the second largest army in NATO after the US.
Turkey to be important partner of UE, important partner for the NATO in the Middle East.
And you are really supplying some of the most important parts and sometimes end products in terms of what the Turkish industry is producing.
Turkey has recently been playing a much more key role for European security and peace, with its new generation air defense systems, drone and laser technologies coming to the forefront. Turkey has a strategic depth on the east-west axis, located on the southernmost flank of the NATO alliance, and a position to control critical waterways, energy supply lines, and trade routes between Europe, Asia, and the Middle East. This vast geographical area was becoming a disadvantage for Turkey to create an effective, end-to-end national air defense umbrella. However, this is about to change completely for both NATO and Turkish defense. In particular, rising tensions in the Black Sea, Russia's moves in Crimea, and increasing cooperation with Ukraine make Turkey's defense investments more critical. While the United States administration and the European Union are making efforts to end the war between Ukraine and Russia, the Ankara government has revealed Gökberk, a laser weapon system that could give the Kremlin a very strong intimidation message in the Black Sea. While Ankara is strengthening its air defense with laser systems like Gökberk, it is also trying to build a fully autonomous defense shield with Steel Dome. This major transformation brings Turkey into a new era in military technology. But how will these systems change the dynamics within Russia, the United States, and NATO? We will also examine how the Ankara government is easing the burden of the United States and the EU with such steps, and what other air defense systems Turkey is producing besides Gökberk. Let's take a look at Turkey's giant defense breakthrough together. But first of all, please don't forget to subscribe to our channel, turn on notifications, and give us a like to be informed about our content. Let's get started without wasting any time. Aselsan has developed Gökberk, a mobile laser system designed to eliminate small and medium-sized unmanned aerial vehicles. Its effectiveness was recently demonstrated in tests where it successfully neutralized FPV drones in various operational scenarios. Aselsan confirmed the effectiveness of the Gökberk mobile laser weapon system during recent tests. The system has proven its ability to detect, automatically track, and neutralize FPV drones, which have become an increasing threat in modern conflicts. In different operational scenarios, Gökberk gave Turkey fast engagement time and high precision, which are key features for its integration into the national air defense system, Steel Dome. Designed as a key component of Turkey's Steel Dome air defense system, Gökberk stands out with its ability to respond quickly to threats with optimized targeting accuracy. Integrated on a 6x6 mobile platform, the system combines a laser weapon with a minimum power of 5 kilowatts with radar and electro-optical sensors for automatic target detection and tracking. The guidance system, developed with artificial intelligence algorithms, maximizes targeting efficiency according to operational conditions. Gökberk operates with dual threat neutralization capability. It can physically destroy targets with its high-powered laser and provide an instant hard kill effect against detected drones. It also has an electronic disruption capability through Aselsan's Kangal jammer, which disables enemy drone communications and sensors, neutralizing them with a soft kill approach. This combination enables it to address a wide range of threats, from kamikaze drones to mini UAVs equipped with explosive charges. The system is designed for high operational autonomy. With advanced cooling technology, Gökberk can operate continuously without performance degradation, making it particularly suitable for long-term use in the defense of fixed sites such as military bases, power plants, ports, and oil refineries. Unlike conventional defense systems that require ammunition replenishment, Gökberk offers an almost unlimited firing capacity, making it a cost-effective solution for armed forces. Furthermore, Its modular architecture allows for future upgrades, including increased laser power and integration into wider network defense systems. Aselsan continues to improve the system by analyzing test data collected under various weather conditions to further increase its capabilities. Investment in directed energy weapons reflects a strategic shift in how defense industries address airborne threats. Traditional systems based on missiles and anti-aircraft weapons, while still relevant, face limitations in countering low-cost drone swarms and mass drone attacks. As a result, governments are looking for more flexible solutions that can address multiple targets quickly and at lower costs. Projects similar to Gökberg are being developed in the United States, Europe, and Asia, where multiple laser weapon programs are underway to be integrated into land, sea, and air platforms. Turkey, on the other hand, aims to strengthen its strategic autonomy and develop advanced solutions in the field of anti-drone defense through Aselsan. Gökberg is in line with a global trend to leverage laser technologies to counter the rapid evolution of asymmetric threats. By combining electronic disruption and physical destruction capabilities, Aselsan offers a comprehensive solution to secure strategic sites and enhance force protection. While testing continues and further improvements are planned, the Gökberg system represents an important step towards the next generation of directed energy-based counter-drone systems. The Turkish wing understands the necessity of the Gökberg laser system much more clearly after the dramatic situations and wars that have taken place in the world since 2022. Recent wars have highlighted the effectiveness of low-cost drones, especially kamikaze and FPV models, used by both conventional armies and non-state actors. In Ukraine, the Middle East, and Africa, these systems have demonstrated their ability to bypass conventional air defense systems and cause significant damage to ground forces and critical infrastructure. In response to these emerging threats, several countries are investing in modernizing their air defense systems by incorporating technologies capable of rapidly engaging small, low-signature targets. The adoption of laser weapons is driven by several factors: significantly lower engagement costs compared to conventional missiles, almost instantaneous response time, and the ability to operate continuously without requiring ammunition replenishment. These characteristics position directed energy weapons as a strategic solution to protect military bases, command centers, airfields, and other sensitive infrastructure. Turkey aims to protect all its strategic military areas and infrastructure facilities with an important system such as Gökberg. So what are Turkey's air defense moves other than Gökberg? As we mentioned in the introduction of the video, Turkey has made incredible progress in this field, especially in the last 2 decades. In addition to Gökberg, Aselsan surprised everyone again with Steel Dome. Turkish defense company Aselsan announced the Steel Dome concept to build a network-centric, artificial intelligence-supported layered air defense system that will protect the entire airspace of the country against all kinds of air threats at all altitudes and ranges. Turkey's Steel Dome consists of about half a dozen early warning, detection, identification, and classification modules connected to an electronic warfare suite and space-based satellites via T-Link. In an example configuration, this layer sits on top of a land-based interceptor consisting of the Korkut self-propelled anti-aircraft gun with a range of 4 kilometers, the GERS autonomous air and missile defense system with a range of 10 kilometers, the Hisar family AOO plus low-medium altitude surface-to-air missile system with a range of 40 kilometers, and the Cyper long-range area defense system with a range of 100 kilometers. Aselsan's solution partner Roketsan is developing a more modern version of the Cyper, which will extend the range of the system to 200 kilometers. This unified defense network with a centralized command and control system backed by artificial intelligence is comparable to the 4-tiered air defense shield of Steel Dome, Israel's Iron Dome with a range of 70 kilometers, THAAD with a range of 200 kilometers, David's Sling with a range of 300 kilometers, and Arrow with a range of 2,400 kilometers. But Turkey's Steel Dome has a shorter range and a missing component to intercept long-range ballistic missiles. The system is expected to operate in multiple scenarios simultaneously in all weather conditions to protect troops, critical platforms, and high-value assets such as ports and energy facilities with minimal supervision. In addition, the Hakim Command and Control Component will host 8 I-class frigates and a 96-cell indigenous vertical launch system capable of launching a variety of advanced munitions and interoperable with the Turkish Navy's planned TF-2000 air defense warfare guided missile destroyers. Under the aegis of the Radnet Radar Link Management System, the Steel Dome is a lethal combo of a holistic set of short, medium, and long-range missiles. There are also significant challenges to the development of this incredible air defense system. One major challenge is that while the Israeli system has been battle-tested and proven effective with over 90% accuracy, the Steel Dome as an integrated layered architecture defense system is still being developed by a consortium of Turkish firms, including electronics giant Aselsan, rocket manufacturer Roketsan, and high-tech defense R&D house TÜBİTAK Sage. Although the system's individual platforms have already entered service, it will take until the 2030s to test and operationalize the desired coverage, situational awareness, precision, and guidance mechanisms. In addition, several technological hurdles need to be overcome to build and implement the Steel Dome. The complexity of engineering and system integration is a major challenge, as the system needs to integrate the latest technologies, such as artificial intelligence, directed energy weapons, and multi-layered defense systems, and guarantee seamless interoperability across various platforms. Steel Dome's threat library, hardware, and interfaces need monitoring and revision to meet evolving challenges. The most serious technical challenge may be integrating next-generation subsystems into the existing structure and ensuring that they work seamlessly with it. Cybersecurity is also necessary to protect the system from potential weaknesses that adversaries can exploit. Turkey must also address the challenges of maintaining operational reliability in practical situations and strike a balance between project financing and the system's high-performance goals. Radars, surface-to-air missiles, and command and control centers are just some of the many components that Steel Dome seeks to integrate into a single effective system. Complex software and hardware interfaces are needed to realize this integration, comparable to the challenges faced by previous large-scale projects such as the F-35 fighter jet, where interoperability issues arose. Maintaining performance and reliability requires seamless subsystem coordination. Since problems in one area of the system can have a cascading effect on the project timeframe, both the integrated system and its individual components need to be thoroughly tested to avoid delays. Then there is the success rate. Achieving Steel Dome's intended performance levels, particularly high intercept success rates, is technically challenging. The system is intended to defend against a variety of air threats at different altitudes and distances, including rockets, missiles, drones, and aircraft. To meet or exceed the desired success rate, Steel Dome will need to undergo extensive testing, optimization, and refinement to guarantee its reliable operation in real-world situations. However, throughout its existence, maintaining an integrated system like Steel Dome presents both technological and financial hurdles. As new threats and technical developments emerge, regular updates are required to guarantee the system's continued effectiveness. However, upgrades to one component may require changes to others, resulting in incompatibilities or outages. Since subsystems are interdependent, it is difficult to diagnose and fix problems without compromising overall functionality. In addition, military funding can be strained by the expense of ongoing maintenance, which includes testing, training, and spare parts, and requires careful, long-term resource planning. System readiness can be affected by operational disruptions caused by ongoing maintenance and optimization. But once all these obstacles are overcome, the Steel Dome will be an incredible deterrent for Turkey. As neighboring countries assess the capabilities of the system and change their own defense plans, the construction of the Steel Dome could change the balance of power in the region. The system reflects Turkey's broader desire to leverage advanced technology in defense and demonstrates its commitment to self-reliance, innovation, and export-led industrial development. By leveraging artificial intelligence and other emerging technologies, Turkey aims to build a multi-layered defense network capable of neutralizing threats at various altitudes and distances. Steel Dome, therefore, represents a transformative leap in the country's defense arsenal, combining cutting-edge technology with strategic foresight to address an evolving security environment. This insight will explore the underlying reasons for Turkey to launch the ambitious program aimed at providing a sophisticated, AI-powered, end-to-end air defense system. The construction of the Steel Dome changes Turkey's relations with other countries, especially when considering its defense strategy. By increasing its military technology know-how, Turkey aims to reduce its dependence on foreign procurements such as Russia's S-400 and the United States Patriots. Given its demonstrated commitment to self-sufficiency in defense technologies, this shift could strengthen Turkey's position in NATO. Moreover, Turkey's desire to establish a stronger military presence in the international arena could affect its standing with both Western and regional powers, as the Steel Dome project demonstrates its intention to take a more active role in international security. In short, when we look at both Gökberk and the Steel Dome air defense system, we can see that Turkey is reassuring the European Union and the United States, and sending a message to Russia for the time to come. Especially when Turkey is discussing the issue of sending troops to Ukraine, Russia's possible aggressive moves, airstrikes, and missile attacks from the Black Sea will be caught in Turkey's defense shield, especially these two systems. In such a scenario, there is no need to even mention what would happen if Turkey intervened against Russia from the Black Sea. In other words, Russia cannot be comfortable with Turkey's presence in the Black Sea, neither on the Crimean Peninsula nor in general. If you remember, Turkish leader Erdogan supported Ukrainian President Vladimir Zelensky on Crimea. Erdogan believes that Crimea should be returned to Ukraine. The Turkish president also broadly supports Ukraine's territorial integrity. In order to realize these ideas, Erdogan may allocate game-changing military resources to Ukraine, perhaps in the future, such as Gökberk or Steel Dome or other such systems. Thank you for watching.